Good morning, friends. Today I'm gonna explain you the topic crystal structure, in that the subtopic unit cell. Now, what is unit cell? The very first basic question which comes in our mind that we have to keep these three important points. We have to remember these three important points, that it is a small block or a geometrical figure in which the crystal structure can be formed in three dimensions. So if we want to define unit cell it is a small block or a geometrical figure in which the crystal structure can be formed in three directions or in three dimensions. Now we have covered these three important points in this one definition. It is a small block or a geometrical figure in which the crystal structure can be formed in three dimensions. So now, what is a unit cell and how can it be formed in three directions or three dimensions? As I said earlier, it is a small block or a geometrical figure or a cube. So we all are aware of how to draw a cube. So let us draw first a cube. We all are aware of the x, y and z direction. So here is the x direction, y direction and z direction. And as I said, it is in three dimensions, so we have to assume it as an x, y, z. And unit cell is a small block, so here it is a small block is formed. Now how to represent unit cell? A unit cell is represented by three vectors A, B and C. Now your question is, where should we place these three vectors? So three vectors are placed in the x. Let us assume that vector A is in the x direction, vector B is in the y direction and vector C is in the z direction. Now why are these vectors, or what is the vector? Usually, vector gives us magnitude and direction. But in unit cell, vector help us to determine or to find the length of sides of unit cell. So it is represented by three vectors which gives us the length side of unit cell. So A is a vector, B is a vector and C is a vector. Now if we observe here, we should think that there should be an angle between this. So a unit cell contains of a three angle, alpha, beta and gamma. So three angles, alpha, beta and gamma. These are called interfacial angles. Alpha, beta and gamma are called interfacial angles. It's a simple basic definition for these angles. Alpha, beta and gamma are called interfacial angles, and the vector A, B, C are called primitive or lattice constant. Now, what is the relation between these three angles, alpha, beta, gamma, interfacial angles, and vector A, B, C. If we add it together plus, so lattice constant plus vectors plus lattice constant plus interfacial angles give us lattice parameters. This is the important basic subtype you should know, that it is represented by three vectors or three independent vectors in three direction. Now what is vector? Vector give us magnitude and direction, but in unit cell vector help us to find the length of the side of unit cell. So what is the length of the units of the sides? X axis, the side B and the side C. It helps us to determine the length of the unit cell. And as we know that there should be an angle between a unit cell, so it is represented by three angles, alpha, beta and gamma. These are called the primitive or lattice constant. This is the basic definition, universal name used for the vectors A, B, C. Now what is the relation between A, B, C? If lattice constant plus interfacial angles gives us lattice parameters. So I hope this is very clear to you, and my video will help you in understanding what is unit cell. Thank you for listening.